Hi, so today I'm going to be showing you how to graph a line in standard form. So what is standard form? Standard form is when we have our equation set up as y equals mx plus b. So what do each of these mean? Well, x and y, like always on a coordinate plane, are the points. So that must mean that this x and this y are the variables, which means they are always changing and they're never staying the same. So we never know what they could be. We could put any number for x and get a y, because y depends on x, and we'll get more into that as we graph the line. So what about the other two, m and b? M and b are what we call constants, which means they stay the same. So unlike variables, they never change. Throughout the whole equation, no matter what you put in for x, what you put in for y, they're going to be staying the same. So now let's break it up even more. What does m and b mean? M is the slope. Now just take a second and think about the word slope. What do you think of? I know I think of something like a mountain, how steep the side of the mountain is, how steep of a slope the mountain has. So if I were to take a mountain, and I take this mountain, and I compare it to this, I would say that mountain 1 is definitely less steeper than mountain 2. You could also say mountain 1 has less of a slope than mountain 2. So that's basically what slope is, just how steep or not steep the line is. So if I were to look at it in a coordinate plane, I'm just going to draw a quick coordinate plane over here. And another one. And this would be the y and x axis, of course. If I have this line that passes through, compared to this line, you can make an assumption that this has a greater slope because it's steeper. So now let's look at what B is. B is our y-intercept. So y-intercept, that should already ring a bell when thinking about the coordinate plane. And yes, it has something to do with the y-axis. So, just forget the y or the t. But let's draw our coordinate plane. All right, so I have a coordinate plane drawn. So again, we know that this is the y and this is the x-axis. Now, any line that you draw other than a vertical line will always touch the y-intercept. So let's look at a line such as this one. What would the y-intercept of this be? Well, it would be right here. So let's say we would mark this as 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Kind of like a quick graph. What about this one? Well, where's the y-intercept? Right here, because it's on the y-axis, and where does it touch? So this would be -2. And if we have a horizontal line like this one, what about this one? Well, it touches it here, -3. It doesn't matter what kind of line it is, other than if it's a vertical line, it's gonna touch the y-intercept. Now, I've been saying a lot about vertical lines and how vertical lines are different. Let's just take a look at one real quick. So we see our y and x axis, and as you can already imagine, if I just draw a line like this, what's the y-intercept? Well, there is none. Anywhere I draw a vertical line, it can never touch the y-intercept. And if I draw a line right on here, the y-intercept is technically every number. It's infinity to -infinity. It's every single number. So these would be a special case scenario. And instead of having an equation that's y equals mx plus b, you might just have an equation that's just y equals mx. But that's a special case. That's for later. So let's look at a number. Let's take y equals 2x plus 3. I'll just take a moment real quick to look at what each of these mean. Y and x are our variables, which we already know. So we're not really going to change them. And our other two, 2 and 3, are our constants. So 2 is our slope, or you could say m, and 3 is our y-intercept, or you could say b. So how would I graph this? Well, first, we haven't talked about slope enough, so let's just go look over that one time. So slope is essentially the change in y over the change in x. And if you still don't understand slope or haven't gone into that, I recommend learning more about slope first and then coming to graph a line, just so it's a little bit easier. In terms of graphing, I like to refer to it as rise over run. So this will come into play when we start graphing. So let's just get out our coordinate plane. Just a quick sketch. And just obviously this is 1, 2, 3, 1, 2, 3, negative 1, 2, 3, negative 3. And this is the y-axis and the x-axis. So first off, whenever I'm about to graph, you want to look at, oops, and I just realized I spelled constants wrong. You want to look at your y-intercept. So what's our y-intercept? In this case, 3. And the reason I like to do it is just because it's a starting point and it's a good place to get you started. So let's count up 3, 1, 2, 3. This is our y-intercept. Now this is why I mentioned rise over run. When having a slope, what is 2 equal to? 2 is also the same as 2 over 1. And now this is starting to kind of look like this. So rise would be, your slope would, you'd count up 2 spaces and over 1 space. Rise 2 and run 1. And since this is all positive, we would just up and right. So you only need 2 points to get the rest of to get a line. So I would just connect these 2 points. Now just to show you, if I were to do the opposite, if I were to do down 2 and left 2, I'd eventually be doing negative 2 over negative 1. And as you know, they cancel out. So if I go 1, 2, 1, the negatives cancel out and it's just the same. So I can go down 2 and left 1 or up 2 and right 1. So now I'm just gonna create my line. And obviously this line is straight and you probably want to use a ruler, but this will make do for right now. So that's one example of doing it. Now what if instead of y equals negative 2x plus 3, we were given, or y equals 2x plus 3, we were given y equals negative 2x plus 3. So let's take a look at that one. Instead of our slope being 2, the slope is now negative 2, but our y-intercept, or b, still stays the same. So let's go ahead and look at the y-intercept and mark it again, b. Now our slope is negative 2 over 1. So that means we're going to rise negative 2 and run 1. But what does rising negative 2 even mean? I could just say it means going down. So I'm going to go down 2. So we're here. But we still want to run 1 to the right. So instead of going here, we would go here because we're still running to the right. And I would just connect these 2 dots. And there you have it. These are polar opposites because the slope is flipped. And I encourage you to try some more questions like this by yourself. Hope this video helped. Thanks for watching.